Today we're going to talk about point-in-time recovery for MySQL. I made a joke about the presentation name. Instead of Back to the Future, now we are going forward to the past. My name is Pepla. I'm father of 3 kids and 3 cats, and in my spare time I work as a consultant at Percona. You can find me at Pepla. It's a bit redundant. I'm currently located in Barcelona, and I'm Catalan, so you can, if you speak Spanish, you can ask me in Spanish if you want. Disasters happen. So failure is not an option, but is a possibility. Even if we design our system taking care of almost everything, there's always the human factor. There are bugs in the code, there are security issues. We can have SQL injection, or we can update a version that of even not our code, a product made by a third party that has a bug, and this bug makes your database inconsistent under certain circumstances. Or even there's a problem, somebody has to push code Friday in the afternoon to fix a bug because the site is down, and then there's a lot of pressure to do something. Quality assurance, you know, they are on holidays, and the code looks fine, but when you push the code, you are merging code from a different thing, and all of a sudden, something you were not expected to run in the database is running. We've seen in the past people running deletes or updates without word clause. And I've seen DBAs doing this. And I've seen DBAs doing this by accident sometimes. For example, not database related, but I removed completely one directory just because I typed the remove command, and I said, oh, I have to fix it and ask for confirmation. And while I was deleting, I pressed return instead of delete. Just in the middle of the removing, I removed completely the name of the file and left the directory. Okay? And it was an accident, but it happened. And I'm not talking about something that happened to somebody. This happened to me. Okay? So disasters happen. How can we avoid or reduce the impact of a disaster? Well, one option is making frequent backups. Okay? So we make frequent backups, we store the backup in a different location, but the problem is that we can't make a backup always making backups. Or in theory, we can't use the backup software to do these kind of things because backups take time. So even if you are able to start one backup after another, during the time of the backup, there's the risk of losing transactions. So there's always a gap between backups. We need a way to store all the changes that happen in the database, okay? And this is what point-in-time recovery is. Point-in-time recovery is restoring a database to a specific date and time. And very important, the specific date and time is previously unknown. You are not doing point-in-time recovery when you do a backup before pushing new code to the production environment. Or you are not doing point-in-time recovery if you, for example, make a backup before upgrading the version. Okay? Point-in-time recovery is done always when you don't know the point in time. Okay? So what do we need to do point-in-time recovery? Well, we need three things. The first one is a valid backup, obviously. It will be used as a base for the recovery. The second one is a copy of all the executed transactions since the backup till the disaster. And the third, which is not easy at all, is identify the transaction or transactions that led to the disaster. In some cases, the third point is not really needed. For example, if the disaster is I removed physically the database files, I don't need to know which transaction caused the disaster. I just need to restore all the transactions that I have. Okay? There's no need to make the effort to identify the transaction because it's clear. And why can we do this? The good thing is that MySQL provides not only but two mechanisms to store all the changes that take place in a database. One is the InnoDB logs, which are always active. And the other one is the binary logs that can be enabled or disabled. Okay. What are the InnoDB logs? Well, the InnoDB logs are a mechanism to speed up how transactions are applied in the database. Performing random writes involves a lot of different I/O operations. So if you want to perform a lot of changes, it's easier to pack those changes together in a sequential file, and when you have time, you apply those changes to the corresponding pages. And also by doing this, you can pack changes. So for example, if you do several changes in the same page, if those changes are in the logs, they can be applied together. Okay, so you reduce the number of I/O operations by packing these operations. So in the InnoDB logs, you have everything that is written in the database. Okay, this means that every change is first written in the InnoDB logs, and then it's written in the table spaces. It's written in each of the tables or other database files. The problem, the problem is that there is not any tool that allows us to use the InnoDB logs to perform point-in-time recovery. This is not completely true. There is one tool that uses actually two tools that use the InnoDB logs to perform recovery. These tools are the database itself. When there's a crash, the database looks at the InnoDB logs and applies all the changes. And this is recovery because we have an inconsistent database and we have the InnoDB logs that we use to make it consistent. And the same with backup software, like, for example, Percon Extra Backup. This software has one of the stages is apply logs. The problem is that currently we don't have a method to permanently grab those InnoDB logs. Okay? Probably this will change, okay, in the future. But currently we don't have this method. The other alternative are the binary locks. Okay? What are the binary locks? The binary locks are a sequential lock of all the executed transactions. Here, it's very important, the concept of sequential. This means that all the transactions that are executed on our database, regardless of the order the transaction started, are stored by the order the transaction was committed. Okay? So we can have a transaction that starts maybe now, but this transaction will not be written in the binary log until we commit this transaction, even if this transaction needs 1 hour to complete. Okay? And the sequentiality is very important because it allows us exactly to find the place where the disaster happened. Okay? If the binary logs would be, for example, parallel logs, it would be more complex. But as they are sequential, it's easier to identify. And why do we have the InnoDB logs and the binary logs? The main reason is the design of MySQL. If you know, MySQL has a two-layer design where you have the MySQL, the SQL engines, the SQL layer, and you have the engine layer. The InnoDB logs belong to the engine layer, while the binary logs belong to the MySQL layer, to the SQL layer. Sorry. The good thing is that this means that the binary logs are engine independent. You can use the binary logs for point-in-time recovery, even for different engines than InnoDB. During this talk, we will talk mostly about InnoDB, but some of these ideas could be used for different engines too. The binary logs are logical, it's a logical log, it's not physical. And when I say it's a logical log, what I mean is we store information about the logical structure of the database. We don't store information about pages or blocks. We store information about tables, rows, and database structures in general. In the first versions, the binary log was storing exactly the SQL statement that the transaction executed. Okay? But in recent versions, I think it started in 5.1, you can store row modifications. I said can is wrong. You must store the row modifications. I'm not going to explain you why, but it's more reliable using a row than statement. You can. There are three formats: statement, mixed, and row. The default used to be statement, then it switched to mixed, and in version 8 it's row. There is a lot of discussion about the performance impact of row versus statement. Some people say that a statement generates smaller binary logs than rows. Because, for example, if you run an update of 1 million rows, and this is one-liner, in the binary log, it will, in a statement, it's just update the whole table. Okay? While in the row format, you need to store all the modified rows. And this is true in the case of modifying a lot of rows. But for a lot of applications, you are modifying just one row. And what is more important, sometimes you are modifying no rows. And in the case of modifying no rows, the binary log in row format writes nothing. But in a statement, it writes the statement. So depending on your application and the patterns that your application uses, it will generate more log using a statement than using row format. And this is not about I run a query that finds no rows to modify. It also applies to queries that modify something that is already there. So if I update a value that is 1 to 1, a statement will write this into the binary log. And row will say, OK, I modified nothing, so I write nothing. Okay. And also, a statement, if the update statement needs to access 1 million rows to modify one row, if we replicate this change, we will need again to access 1 million rows to modify one row. But in the case of row format, if you access one row, you will write if you access 1 million rows but modify one row, you will write just one row in the binary log, and this will be replicated just as one single row. So it's not really true that a statement is best for performance. It depends on the case. For some cases, probably it will be. In other cases, it will not be. And also, remember, remember that this is a sequential log. So we write things sequentially in pages. So probably we'll pack several changes together, and the impact in performance will not be that big. Also, we need a consistent backup. We need to know the position of that backup in the binary log to avoid applying twice the same transactions. What does this mean? Sorry? The transaction is written into the binary log before being committed. It appears in the binary log depending on the value of a variable called sync bin log. So the thing is that I can write into the binary log, but if I don't flush, maybe it's not written in the binary log. If you want to have 100% durability, you need to make sync bin log equals 1. Okay? But this depends also on the underlying storage. If you have batteries and these kind of things, then you can relax this. Okay? Well, we need to know the position of the backup in the binary log to avoid applying twice the same transaction. Clearly, we are going to restore a backup, and we are going to apply the transactions since that backup until the disaster. So we need to know the position of the backup, because otherwise we can either apply transactions after the backup and miss some transactions, or apply transactions twice. And this, in one case, we would have a corruption or an inconsistency, and in the other case, probably the point-in-time recovery would fail just because we are trying to modify data twice. How can we get the position of a backup? Luckily enough, almost all the tools that are able to make a consistent backup already provide this information. In the case, for example, of Percon Extra Backup, stores the position in a file called extra backup binlog info file. Okay? MySQL dump stores the information at the end, at the beginning of the dump file. At the beginning of the dump file when you use this option, and my dumper stores the position information in the metadata file. Okay? So in any case, if we use these tools and also the enterprise backup of Oracle stores this information, we have the initial position for the recovery. Okay? To GTID or not to GTID? Well, there is no question. What is a GTID? A GTID is a global transaction identifier. A global transaction identifier means it's an identifier for each and every transaction that happens in our database. Why is it global? Is it global because it's supposed to be unique for your database in all the universe? Okay. In theory, there shouldn't be any other databases out there generating the same GTIDs that you. How is this done? There is a UUID of each database that is generated using the different factors. So, in theory, your database has a unique identifier, and then you have also a sequence of transactions. So, UUID plus sequence is a GTID. In the past, the positions in the database were expressed as a combination of the binlog file and the binlog position. And the binlog position was something as simple as the number of bytes of the binary log file in that moment. So if somebody says, well, file 1 position 1000, this means file 1 and the 1000 bytes. So by keeping track of all the executed GTIDs, an instance is able to get the position automatically. Here is the trick. The trick is that as I have GTIDs that identify any transaction, I know all the changes that I have executed. And I can, if I want to do point-in-time recovery, I know which changes I haven't executed yet. So this is an example that I used for the presentation. I create a table called point-in-time recovery, quite simple. I inserted 3 rows, and after that, I made a backup, simple too. I did not use anything complicated. MySQL dump, all databases, the events, routines, in a single transaction to make sure that the backup is consistent. And as I said before, I store the position in the backup. If we look at the contents of the backup, here we will see that, I'm going to move, but here we will see the GTID executed, and we also see the binary log position. So here it's the position, and here it's the binary log. How can we capture the binary logs? There are different methods to capture the binary logs. You can copy physically the binary logs, just using the operating system command. But the good thing is that MySQL binlog is a utility to process the binary logs. It has an option to read the binary logs and store them locally. So in theory, we can, in practice, we can take one database and from another server execute this command. We read from a remote server. We provide the IP address. raw format because we don't want the binary logs to be processed at all. We just read and write. And here we are mimicking the replication process. If you know, in MySQL you can set up a replication that allows you to copy all the changes that happen in one database to another database. What we are doing here is acting as a replica. And to act as a replica, we need to connect to the database. I use these credentials, extremely secure. And the last two options is the stop never. This means that I'll be collecting the binary logs forever. And the last one is the first binary log I'm going to request. Beware, because stop never does not mean forever. Stop never means as long as I'm able to retrieve the binary logs. For example, if I stop the database, my SQL bin log will stop. Okay, and you need to restart it. Otherwise, the process of copying binary logs will not continue. If there's an incident in the network or something like that, MySQL bin log will time out. Okay? So if you are going to use MySQL bin log to grab the binary logs, you need to monitor that it is running, and if it fails, you need to go to the last file and restart it with the last file to recover it. Okay?
You mentioned it already, but I'm blanking. Which part of the stack is writing the binary log? Is it the MySQL engine or?
It's the SQL engine.
Okay. The stop never, it won't stop when it runs out of bin logs, right? It'll just wait for more.
It just waits. Okay. It's a bit confusing, but it's the SQL layer. Okay, and the answer is quite simple. The binary logs are generated regardless of the engine. Okay, so if we use MyISAM or whatever engine we use, binary logs will be generated. So now the next step is we made, sorry? Is the streaming the bin log?
Like where are we putting that entry once bin log has been written? Is it streaming?
It's written in the actual directory. So I read the binary logs from that host, and I store locally.
So is it like folding continuously? Is it running?
Yes, but this is not that strange. This is something that MySQL already does for replication. So there is a protocol that supports this. When there is a change and I have a replica, I'll notify the replica. It's not like, have you something for me? Have you something for me? No, it's a communication between the server and, in this case, the pseudo replica. And this communication, if there's a new binary log entry, there is a process in the server that notifies the replica and sends the binary log. So it's not a permanent polling. Okay? It's a bidirectional communication. When I have a binary log, I'll send the binary logs to the replica. Okay? This does not bring, it brings load, but it's, I don't know, maybe 1% of the CPU, or well, depending on the number of CPUs you have, but it's very few. Okay. Okay. So the next step is we already made the backup. We are capturing the binary logs, and now I insert 3 additional rows, and I truncate the table. Okay? So this is simulating a disaster. Unfortunately, disasters are not like this, tend to be a little bit more complex, but we will discuss this later. So now we have, what do we have? We have a backup, we have the binary logs, and we have a disaster. Actually, we said we need 3 things because you don't need disasters, they come, okay? What's missing, what we need now is to identify somehow the moment in time that the disaster happened. How can we do this? There is a command, show binary log events. It's a pity because I don't know if you can see it, but in the bottom part of the screen, it's here. I guess you can see it. Well, here it's, if you make the effort, you will see truncate table, okay? Okay, so I'm not supposed to move because the recording, but here, what we have here is the name of the binary log. We have the position. We have the event type, which is really important. In this case, it's a query. It's a query. It's executing something. But we also have write rows. These write rows that are applied in the table scale 19 PITR are the inserts I made before. Okay, and here we have the truncate. So with show bin log events, in this case, we would retrieve the position of the disaster. So everything is fine. We are very happy. The only problem is that usually your system is really very busy, and your binary logs have maybe millions of rows. Okay? This is not going to happen. Show binary logs, show bin log events with 24 or 30 events. You have millions of events, okay? Or thousands of events. That's enough to drive you crazy trying to find the event. So here the trick is use, there's a command called pager in MySQL that allows you to define the pager. In theory, you should use more or less, but you can do some advanced things with the pager. For example, you can use grep to search things. And then when we run the show bin log events, it will search for the line that contains truncate table PITR, and it will show 1 row before. Okay? So in this case, again, we have the position on the 2 left columns, and in the first row, we have the GTID of that change. So we can use this kind of filters to capture the position. But if we return to the previous screen and make again the effort, we see that sometimes the change is the exact SQL command is not here. Why is it not here? It's not here because I said that the binary logs store rows. But in the case of DDLs like truncate, it stores the statement. Because a truncate, it makes no sense to store the whole removing of rows. It's easier to just store the DDL. And this means that in the event is easy to see. But if the disaster, instead of being generated by a truncate, is generated by an update without where clause that updates all the amounts of your invoices to the same amount, then you will find events like the ones there. You will find right rows events on that table. So in this case, show binary log events would not help that much. You can still do things with this information. For example, if you remember, I said that the position is the number of bytes. So if we see that the distance between two events is very big, this means that this event modified a lot of rows. Okay? So we could try to process this a little bit and get this information. The problem, again, is that probably this will return a ton of rows, and you can't create well, maybe somebody can, but it's difficult to create a pager command with grep that compares the value of the previous and gives you the number of the distance between two events. The other option we have is use again MySQL binlog. MySQL binlog initially was created as a decoder of the binary logs. Okay, so in the case of row format, you can run MySQL-b for verbose, and then base 64 output decode rows, and this will dump all the commands that were executed. In this case, I wrote a small one-liner that does something similar to the previous grep, that is able to give us the GTID, the position. We have the position because we know the binary log, and we have the position, and then we have also the GTID. Important. This was a test, and I had just one binary log file. Sometimes you don't know when the disaster happened, and then maybe you have 300 or 3,000 binary log files. Okay, you need somehow to guess, or otherwise you need to process all the binary logs. There is no option. One of the tricks is, for example, is searching for binary log files that are really very big. Okay, because transactions are not split in the binary log. So in theory, the binary log files have a fixed size. But if we have a huge transaction, we will exceed that size. Okay? So if you look at your binary logs and all are 1 gigabyte, and you have one binary log which is 10 gigabytes, probably does the update. Okay?
If you've got multiple binary logs in your directory, do you wind up just doing an operating system command to find out what to sort them in reverse timestamp order to find out what the latest one is?
Well, the binary logs are sorted by sequential, so. And you have the date of the file. So this is, obviously, in the header of the binary log, you have timestamps and you have a lot of stuff, but if you have a ton of files, having to open them and process them is slower than just looking at the operating system. Well, finding the position is not trivial. Why? We've seen we can have multiple similar events we can have, imagine that we have, every hour we run an update that updates 100,000 rows, and one of these updates was wrong. Well, then identifying the rows is not easy. So finding exactly the offending, even writing the command to grep can be complex. Sometimes the event has several lines. It was written in several lines. So when you grep, you need to make a complex search because it's not an update of the table. It's what you're looking for is in the where, and this is the third line, for example. And sometimes you don't know this. So the DML are not visible in the show of binlog events. If you have a lot of huge, massive binary log files, it can be really time-consuming to process them. Sometimes you don't know the exact syntax of the query, and something even worse. Maybe the disaster is not just one query. It's a bunch of queries executed together. It's one query that is retrieving data, then modifying one table, and another table, and another table. So identifying exactly the position can be complex. One of the clues you can use, as I said before, is the position of the following event. It's also useful to use the size of the files. It's important to understand, it's not easy to make it something that can run by automation. So this kind of recoveries, even if you try to write a run book for point-in-time recovery, it's something there are some lines you say, investigate, search for, okay? The important thing is that you need to understand the process. Because when you do this, there's a disaster. Okay? There's data loss, probably your site is down, there's business pressure, you need to fix this quick because we are losing a lot of money. So if you practice the process and you know the process, then you can speed up and reduce the time you need to fix the issue. Well, what we are going to do now is the traditional way of doing point-in-time recovery. We restore the backup. In this case, it was a dump, so I just execute the dump. And if I check the contents of the table, we see the first, second, and third rows that I inserted before the backup. Then I apply the events. I use, as I said before, MySQL binlog is a tool that decodes the binary logs and transforms them into sequences, into sentences that can be applied by the database. So in this case, what I do is MySQL binlog, -- stop position, the position we retrieved before, pipe MySQL. This applies all the changes. And if I run the query, you will see that we have first, second, third row pre-backup and the post-backup. So I did a point-in-time recovery. Life is wonderful. No.
So for clarification, that 1176 was the position right before the truncated.
Yes. Yes. We could not use the position and use the GTID, but this is something we will discuss later. The problem with MySQL binlog is that it applies even sequentially. So imagine that we make a backup once a week, because our database is really very big, and we don't have time to make backups that often. and we have a ton of binary logs. We make backups on Sunday night, and somebody decides to break our database Saturday morning. So we have a ton of binary logs to process. If the process is sequential, it can take days to load all the binary logs. Another problem is that we can't tell MySQL Winlog to stop on a GTID. We can tell to stop on a position, but not on a GTID. Okay? So in this case, we need to provide the binary log file and the position in the file. How can we make this faster? Well, the trick here is that the database of MySQL already knows how to apply events in parallel, because this was implemented to perform parallel replication. So what we are going to do is trick somehow the database using replication to be able to apply those events in parallel. Everybody knows what replication in MySQL is. It's just the binary logs that we've seen that are applied in another database. So the same process we did here, but it's done by MySQL itself, allows us to, I make a backup of a database, I restore the backup, I say, you're a replica, and it collects all the binary logs and apply all the binary logs. Okay? And then we have two databases that are synchronized. All the changes that are written in the source are applied on the replica. We can make the process faster by using parallel replication. To do this, we have two options. The first one, which I will describe just, is, is we create a dummy instance where the binary logs are stored. So let's imagine that we write the binary logs on a storage server. Okay, have a box that just has plenty of disk, and the binary logs are written there. I can do one thing, is I just install MySQL there. I start a dummy instance with the minimal requirements. Before starting the database, I remove the binary, if there's any binary log from the dummy instance. I move my binary logs to the location. I generate a file that is the index of the binary logs, and I start the instance. Okay? And then I tell the database that I recover from the backup to become a replica from this instance. Okay? It's funny because it will provide information about binary logs that are not binary logs, but it works. Okay? This method is very useful if you have multiple replicas that you need to rebuild. Okay? If you have a lot of replicas that you need to rebuild, you restore the backup on all the replicas, you apply the binary logs on all the replicas, then you have all the replicas are at the same level, and then you can rebuild your replication topology as you want. And as we are using GTIDs, it's self. There is another method to do this, is we trick the server, making it believe that there are relay logs. So instead of taking the logs and putting the logs on a dummy server, what we do is we place the logs as if these logs were coming from a replication process. Because the replication process consists in I connect to the source database, and I ask for the binary log, and I store this binary log in a file called relay log. And the good thing is that the format of the relay logs is identical to the format of the binary logs. So we just need to copy the files, and that's it. So in this case, what we do is, here I'll describe the process. As we want to run the process in parallel, we change the replica parallel type to logical clock. This, if you are using 5.7, change the word replica by slave and the word source by master, okay? Because there was a change, and I'm using the recent syntax. Yes, true. Well, change the parallel type, increase the number of workers. Then we copy the binary logs. If you look, we change the name to relay bin. Anchoa is the name of my computer. It's the anchovy in Spanish. We set the ownership to MySQL. Okay. We generate the index of relay logs. We have to do one thing. There's one variable called server ID. Each server in a replication environment has to have a different server ID. As we are replicating binary logs that come from myself, what I'm doing is temporarily I change my server ID. After that, I configure replication to a non-existing host, specifying the relay log and the position 1, because I'm going to copy all the relays. I could use the position, the required position. In this case, for this example, it fit position 1 because we are running GTAD. And this is what happens. Select star. I have the 3 rows after the backup. I start a replication until the GTAD, and all the missing rows are back. After that, we just clean replication, restore the server ID to the original value, and we reset. What happens with the transactions that were executed after the disaster? Well, usually if you look, thanks that we have GTADs, if you look at most of the documentation, they will tell you that you can use, exclude only the GTADs of the offending transaction. By doing different methods that are explained here. But just do this if you are sure that you are creating a consistent database. Why? Because there are relationships between the content of your databases, and there are processes that do stuff with the information you have. So for example, if you have an statistics table that gives you the average amount for the invoices of the last hour, during the time you experienced the disaster, this data will be wrong, okay? So sometimes it's not a good idea to reapply everything, even if this data is not exactly affected by the truncate or the update. Okay? You need to know the relationships internally in the database. Well, questions?
So you're saying stop instead of reapplying anything you didn't need?
Yes. I think you need to be careful with what you do. We are hiring, and feel free to contact me if you